What's up, geeks and gamers, and welcome back to my channel. In today's episode we're going to build a budget $500 gaming PC for 1080p gaming, because there are people out there that say it's not possible, and we're going to prove them wrong. Roll the intro. With a constraint to only spend around $500, we are of course going to make some compromises. Let's start with the mainboard. We are going for the LGA 2011 platform with a Xeon 8-core 16-thread CPU. The chipset is X79, which is a bit older, but currently those mainboards are produced again. Just search on Amazon or eBay for X79 mainboards and you will be surprised, there are even some with M.2 slots. If you want to go really cheap, you can find tons of them on AliExpress, but beware of possible import taxes for your country. As mentioned before, for the CPU we're going with a Xeon. It's the E5-2690, which is capable of turboing up to 3.8 GHz on single cores. One cool feature about this platform is the support for DDR3 ECC memory. So built-in error correction makes this a super stable platform for all kind of workloads and of course for gaming. We are going for not 8, not 16, but all in with 32 GB of DDR3 1600 ECC memory. As this is server RAM and servers get upgraded very often, the market is full of those RAM modules for cheap. To keep our 8-core CPU nice and cool, I chose the Alpenföhn Ben Nevis air cooler. It has a really great price performance and comes with all kinds of mounts for different platforms. I snagged this one for only $25. Now for the storage. I bought a brand new Kingston 480GB SSD as I do not trust used hard drives or storage devices in general. The SSD will give us great performance for loading games fast and a snappy Windows experience. The power supply is also brand new. It is an Enermax 500W non-modular PSU. Why non-modular? To save money, and with my case choice it does not matter if there are unused cables dangling around. You won't see them anyway. And now for something we could have left out to save money. The case offers USB 3 front I/O, but the mainboard does not provide USB 3 headers. So I bought a PCI USB 3 adapter for $10. Does not break the bank, but sure, it is nice to have. Okay, what else is missing? The graphics card, of course. And this is the biggest compromise due to the current ongoing GPU shortage. A year ago I would have opted for a 1070, but we have to buy what we can get for a decent price without exceeding our budget. I went for a used RX 580. Unfortunately, the 4GB model. Will 4GB be enough for 1080p gaming? We will see. I still had to pay €175, and from what I saw on eBay lately, the prices might already have increased yet again. Okay, time to put it all together. No, wait, I forgot to show you the case. I got a Colink Satellite Micro ATX case off eBay, new for €35, a bargain. I soon regretted buying that case for some details. You will see during the build process. I will slow down the video there and tell you about my problems with the case. But now, let's build. Okay, here's the first issue. The power supply just fitted in there. It is such a tight fit. The case manufacturer says mainboards up to 22.6 centimeters by 18 centimeters fit. This board has a width of 18 centimeters, and there is no space left between the power supply and the mainboard. My issue? I still have to fit the fat 24-pin power adapter from the power supply onto the mainboard, and there's literally no space. I managed to squeeze it in there with force in the end, but I would definitely recommend a mini ITX mainboard for this case. Now for the fun with the graphics card. Coling says the case fits GPUs up to 280mm in length. Awesome! This card has only 275mm, according to MSI specs. But how the hell are you supposed to get it in there unless you can beam it in place? There's no way to maneuver it in place unless you tilt it, but then you can't get it into the slot and it is a big mess. Yes, the graphics card is in there, finally. I did not only remove the power supply and the cooler, but also the I/O shield over the ports of the graphics card. I then screwed that shield into the case first, then jammed the graphics card in there in a sideways slide and reattached the screws to the I/O shield of the graphics card. Yes, 275mm cards fit in there if you kind of take them apart first. Oh, and yes, that fan at the back of the case is now an intake fan. Now for something that was my own stupidity. As you might have noticed, the case offers space for graphics cards with up to 2 slots of height. Those slots are accessible at the back of the case, but I still wanted to add my PCI to USB 3 adapter for the front headers. In the end, I had to remove the I/O shield from that PCI card and just stick it in its slot without screwing it to the case. The 2 additional USB 3 ports at the back are of course lost, but at least the front I/O is now fully functional. And here it is, our fully working $500 gaming PC. Peripherals and rubber ducks not included. By the way, the mainboard has 6 USB 2 ports and 2 USB 3 ports at the back, so plenty of ports for all your devices. But how does the PC perform? Let the benchmarking begin. In general, you will notice that I prefer to use benchmarks built into the games. It is a reliable way to get constant results and rerun tests easily. Also, comparing these results to other computers is super easy. So if you have any of those games, you can test your machine against this budget build. All tests are performed in 1080p. With that out of the way, let us start with Shadow of the Tomb Raider. As you can see, with a medium preset, we end up with an average of 75 FPS, only dipping down to 71 when switching to the high preset. The highest preset gets us down to a still great average of 61 FPS. As Shadow of the Tomb Raider is not a competitive multiplayer or fast-paced shooter, I would have no issues using the highest preset and enjoy the stunning graphics. If you are allergic to any dip downs in frame rates, you might prefer the high preset, though. Furthermore, it seems we get kind of GPU bound but not CPU bound in this title, as I noticed when running Afterburner to verify some numbers. F1 2020 is one of the games that love AMD graphics cards, and even with this old 580 and only 4GB of VRAM, we get amazing results. With the medium preset, even the 1% low still hits 118 FPS, while averaging at 134 FPS and maxing out at 152 FPS. The high preset still hits 104 FPS as the minimum, averaging around 122 FPS and reaching 143 FPS max. Switching to the ultra high preset finally gets us below 100 FPS for everything except the max FPS. The average is around 86 FPS, while the lowest FPS hits 63, so still above the magic 60 FPS mark. Honestly, I would have no issues running this game at ultra high settings all day long on our budget PC. Next up is Metro Exodus. This is one of the harder to run titles, and let me tell you something beforehand. The game runs better than the benchmark, or to put it the other way around, The benchmark is much harder on the hardware than the game itself. With the medium preset we average around 66 FPS, dipping down to 37 as the minimum and maxing out at 94 FPS. Switching to the high preset cuts down the performance even more. This game is hardware hungry in its benchmark. We reach a minimum of 22 FPS, an average of 42 FPS and a maximum of 66 FPS. The ultra setting is even worse. 19 FPS minimum, 34 average and 51 FPS as the max make it a hard to run game on our budget PC. Although, as mentioned before, the benchmark performs much worse than the game itself, so probably you could get away with a high preset, but honestly I would stick to the medium preset with this game and our low-end hardware. The next game is Assassin's Creed Odyssey. Oh, a Ubisoft title, and you know what that means? Yes, badly optimized, bad performance. During the benchmark, whenever the camera flew through the door, the FPS dropped for a second to super low values, then recovered and was stable again for the rest of the benchmark. I have no idea what the problem is, but I can say that the game itself runs smoother than the benchmark. You probably should ignore the low FPS in this chart, as they are the result of this weird dip down at the same spot every time. Taking that into account, I would still stick to the high preset in this game with our budget PC. I'm not going to read all the numbers of this game to you, as you can just pause the video if you really want to dig into them. Far Cry New Dawn. Yes, another Ubisoft title, but this one gives us some interesting numbers and insight. What do you notice instantly? Yes, no matter the preset, the FPS numbers are all quite similar despite different presets. So I cranked up Afterburner. The GPU is sitting at 100% all the time, while none of the CPU cores hits 100%, mainly not even above 60%. This means we're heavily GPU bound here. This old Xeon could easily deliver much higher FPS in this title with a better graphics card. That is the good news. The bad news? Due to the shortage, any better graphics card would have killed our budget. But perhaps that is a nice upgrade option for this machine when prices drop back to normal. So it seems that our budget PC can run Far Cry New Dawn at ultra settings all day long, and you will have a great gaming experience. Awesome! Now for a highly optimized and awesome looking title, Wolfenstein Youngblood. This title also is the first and the only title where we run out of VRAM with our 4GB RX 580. The game warned me when switching to the Ultra preset that there will be not enough VRAM, so I skipped running the benchmark at Ultra settings. Let's start with the Riverside benchmark. The high and normal preset are pretty close together, just some FPS apart. This title is really well optimized to reach those numbers and averaging above 100 FPS in both the high and normal preset. Now for the LabX benchmark. It is said to be harder to run. Interestingly, this only affects the low FPS. With still around 55 at the high preset, I would stick to that, although the 70 FPS of the normal preset are way above that. The 55 is still close enough to the magic 60 FPS you want to aim for. So all in all, our budget PC can run this game at the high preset with amazing performance and FPS numbers. Great! And now for a AAA title that is hard to run, Red Dead Redemption 2. I was a bit lazy here because there are so many things to tweak and there are so many presets. I just left the slider in the center where it was. I think they call it balanced, so to say balance between performance and quality, and ran the benchmark. As you can see, we max out at 91 FPS while averaging at 60 FPS. This kind of low 46 minimum FPS is no party pooper, to be honest. This is a single-player open-world title, and you probably will never notice those short FPS drops if they ever occur in the game, and they will be not game-breaking. For our budget PC, it is really amazing to be able to run this game with those great results. So, you definitely should not fear to run AAA titles on this little machine. And now for something I've been asked to include in my tests. The power draw of the machine during different scenarios. This also puts an end to discussions like, is that PSU powerful enough? As you can see, the machine draws almost 80 watts idle. That is quite a lot, but the Xeon is the culprit here. If we crank up Cinebench to max out the CPU usage, the power draw goes up to about 170 watts. Same happens, for example, when you compile code and utilize all CPU cores or render videos just on the CPU. Next up is gaming. When the RX 580 kicks in, the power consumption goes up to about 300 watts. Performance has its price, I guess. Now, artificially forcing the CPU and GPU load to 100%, we max out at 350 watts. But I do not think this will ever happen during normal workloads, and people who need this probably do not build a budget PC like this. I guess the 300 watts while gaming are a realistic maximum power draw for this machine. With a 500 watts power supply, we are totally safe and still have some headroom, example given, to upgrade the GPU in the future to a more powerful one, but also more power hungry one. Okay, my conclusion for this build. It is perfectly possible to build a 1080p gaming PC for 500 bucks. Although the upgrade path for these machines are kind of limited, you can still upgrade the GPU when prices return to normal. Till then, you have an amazing workstation/gaming PC that is perfect for 1080p gaming, and it did not break the bank. Next up, I will test more alternatives to heavy gaming PCs, including the new Intel NUC with the 11th Gen CPUs and Xe graphics. Furthermore, we will revisit the 4750G AMD APU. With the latest AGESA and driver updates, there seems to be a slight increase in performance and stability for that APU, and I definitely want to move it to a better case. The video for the original build can be found on my channel. Also, I will review an i9 all-in-one tiny small form factor PC from China that features an included 1650 GTX GPU. This will be awesome, and as I'm sure you do not want to miss that, make sure to subscribe and ring that bell. And as always, thanks for watching. Alpha, over and out.